Hello. Third homework lecture, the octet rule. We're going to look at how electrons achieve stability through the formation of chemical bonds, or atoms achieve stability through the formation of chemical bonds. Ionic, covalent, and metallic bond formation is covered here. And we're also going to look and see how energy is involved in the formation of a chemical bond, or the making and breaking of chemical bonds. Okay, so here we go. The octet rule simply says atoms want to gain or lose electrons, the valence ones, in order to obtain a stable valence shell. For most atoms, it's 8 valence electrons. Hydrogen and helium are the only exceptions. These ones will be happy with just 2. So it's the octet rule, because everybody wants 8 valence electrons. Hydrogen can handle 2, so that's why. Ionic bonding in the octet rule. So atoms, brackets, charges, and dots. What the heck does this even mean? Well, it's simple. Metals completely transfer their valence electrons to nonmetals, leaving both with stable valence shells. Atoms, brackets, and charges and dots are about to show up in these pictures. Okay? And I'm going to explain what they mean soon enough. In this particular scenario, I want you to draw the picture. So pause it and draw these Bohr diagrams and the transfer of electrons here. You got atoms, NaCl, charges, positives, negatives, dots, electrons. The one thing mixing is brackets. I'm going to show you how to do that. So pause it, draw down the diagram. Okay, you're back. Now, calcium chloride. Again, I want you to draw the picture here. There's pictures of atoms. There's pictures of atoms with charges. And there's many dots in here for the electrons that had moved around. The 2 electrons that were involved in this transfer are highlighted with the little like that. Okay? So, pause the video, draw it. All right, welcome back. Last one made it simple for you. This one includes all the atoms, brackets, charges. Okay, the one thing that might be missing is some dots in here, but that's okay. This is a bond between an ion and a polyatomic ion. That polyatomic ion is really difficult to show with all the electrons around it. So we simplified it with these bonds and dots. Okay, so we've got atoms. We got the brackets. We got our charges. And we got some dots to show our electrons. Okay, so that's what atoms, brackets, charges, and dots are going to mean. And let me make it a little clearer for you. Pause the video, draw that picture. Okay, we're back. Covalent bonding. Nonmetals share their valence electrons with other nonmetals, leaving both with stable valence shells. So before we get to the atoms, brackets, charges, dots, we've got to do some covalent bonding too. Here's some examples. And I do want you to draw the process. You have 2 elements, hydrogen atoms, that combine to make H2. How? They pair up those lone electrons to make a duet. They share it, and it becomes a solid line of a chemical bond. HCl. Here's another one, step by step, how it forms the molecule. You have hydrogen with 1 electron, chlorine with 7. Hey, you need another electron? Yeah, so do I. Let's share these electrons is here. So they do. Those 2 lone pair electrons match up, form a duet. Chlorine completes its octet, hydrogen completes its duet, and boom, you got HCl, the molecule. H2, oh yeah. Well, hydrogen has 1 valence electron, oxygen's got 6. So oxygen needs 2 hydrogens to fill itself up, and hydrogen just needs 1 to fill its shell, so it does. Step 1, step 2. Step 3 is where we take those paired up electron dots between atoms and draw a solid line. So draw all these pictures. Metallic bonding, simple. Memorize it though. That's a metal plus a metal. Remember, ionic, a metal plus a nonmetal. Covalent, 2 nonmetals. Metallic, metal plus metal. It's the only options. There's only 2 types of elements on the periodic table, metals and nonmetals. There's only 3 ways to combine the different classes. So metals exist in a mobile sea of electrons. So it's like basically the positive nucleus with its kernel electrons, and the valence shell is like sloppy. It will go anywhere. It acts like an extended blanket. Okay, so each atom loses its valence electrons, contributing this massive sea of electrons. That's really how metallic bonding works. The nuclei of these atoms are kind of held in place with a crystal structure. But that's going on. Thermodynamics and bond formation. Well, thermodynamics is a fancy way of saying energy. Okay? Bond formation releases energy. If you have two atoms that are independently unstable because they do not have a full octet or duet, they want to get together. When they do, they go to a lower energy state and release energy as a result. So atoms have lower energy as a result of bonding. And here's a picture of a reaction diagram that shows an exothermic process, which is bond formation. And I want you to draw it. Sketch it in there. Okay? Good. Now, bond destruction requires energy. If you're mad stable once you're bonded with somebody, you're going to have to get pulled apart in order to do so. So you got to put a lot of energy in to break bonds. Therefore, the atoms finish with higher energy. So if they're at low energy in the first place because they're mad chilled out and stable, they'll finish with higher energy and probably be more reactive. Okay, so again, I want you to sketch the picture. Okay, thanks for sketching the picture. And moving on. There's no practice page in this packet, so there's a Google Classroom assignment to do instead. And as promised, the next video is all about atoms, brackets, charges, and dots. I got my slides messed up. So thanks for watching this one. Do your Google Classroom assignments. After this one, we're going to start picking up the pace and we're going to have some more practice to do. But remember, do your practice pages after you take the notes to demonstrate to everybody involved in this education process that you can do these things. Thanks for watching.